All right, so we're going to wrap up our discussion about area by discussing circles, and so we're going to focus on not just area of circles, but some other parts of other measurements we can do in circles as well. But to start off, we want to define some vocabulary that you're going to see once we get into these measurements. So the first thing we're going to do is just talk about, well, what is a circle? Okay, so a circle is defined as the set of points that is equidistant from the point that we define as the center. So in our picture here on the left-hand side, you can see that we have this point D, okay, and the definition basically says that we should be able to measure from point D in any direction, which means straight line in any direction to any of the edges of the circle, and to any of those points it should be the same distance. That's what equidistant means, okay? So not only that, but we can also use that center point to name the circle. So the way we usually do it is if I asked you to name this circle, a lot of times we'll use the symbol, which is a little circle with a dot in it, just like our picture over here, to signify the center dot, and then we'll use the letter that we use to name that point in the center. So to say circle D, you'll sometimes see it written as shorthand, that little circle symbol. Okay, so some of these segments that we've drawn in here we can also give names to, and you've probably heard these before in previous classes. So we have this segment called the diameter, right? So the diameter is going to be defined as a line segment where both of the ends of the line segment are on the circle itself, and it has to pass through the center, right? So if you take a look at this line segment AC here, right? AC is definitely ending on the circle. That's the A and the C. They are both points on the circle itself, and it's going through point D, which is in the middle. Okay, and that's very different from the radius, which also goes through the center, but when it hits that center point, it stops. So now one of the endpoints is the center, and the other one can be any other point on the circle. So I'm giving you an example, and that's this point, this dB. But I want you to remember this about a diameter and a radius, and that's that we can actually draw a radius or a diameter from any endpoint to any endpoint, or for a radius from the center to any endpoint. So even though I drew dB, there's actually an infinite number of radius lines that we could draw. And just to give you one simple example, I could, for example, go out of the center of the circle and go down here, and even though I haven't defined a point here, I could just create another letter and call this one F, right? And I could call this dF also a radius, right? So just because we haven't drawn a radius doesn't mean that it doesn't exist on the circle. We just are specifying one of the many radius lines that we could have, okay? And so here's the last important point about a radius line, and it's really the relationship between a radius and a diameter, okay? This says a radius is always exactly half of a diameter, which means if you draw two radius lines that are going in opposite directions, they're going to create a diameter. So again, that's probably something that you've heard before, but I just want to remind you. Okay, and so here's our last definition hiding down here. It's called a central angle. Okay, and a central angle is something that we heard when we talked about regular polygons, and it's pretty much the same, right? And so it is any angle whose vertex is on the center of the circle, and it's usually created by two radius lines. So if you take a look at, again, back up here at our picture, okay, let me erase what we have so far, so we can redraw ourselves a central angle. And I'm actually going to get rid of this extra diameter I drew. Right, if I were to go back here and grab my highlighter again, we could say this angle right here from C up to D and then from D over to B, right? This is an angle right here, okay, and the center is point D, right? So this angle right here would be the definition, would be an example of a central angle. Okay, so we're going to start off by talking about, again, just naming conventions. We're not going to do any measuring. Okay, and so we have one more thing that we have to talk about, and that's that the idea of arcs. Okay, so just generally, an arc is any section that is an outside edge on the circle. Okay, so if I were to instead of saying, like, let's go all the way around the circle, I'm just going to put 2 points on the circle, and I'm going to say I care only about the circle from one point around the circle until I get to the other point. So it actually ends, okay? So we're going to spend the next video actually measuring these things, okay, and then figuring out how long some of those line segments are. But first we have to talk about what type of arcs exist and how do we name those arcs so that we can discuss them in the next video. Okay, so we have 3 types of arcs that could exist inside of a circle. The first one is called a semicircle, which that's, again, probably something that you've heard. That is exactly half of a circle. It's going to cover half the circle, and the way that we're going to know that it is a semicircle, Okay, if I again take a look at this picture that I have up here, a semicircle is always created. I am trying to grab my right pen tool. Okay, it's always created by points that could create a diameter, right? So you can take a look at this picture here. If I were to go from T over to R, I pass directly through the center, which means I drew a diameter from T to R. And so that means that if I were to go from R and trace around the circle and end at T, and it doesn't matter if we trace above the diameter or below the diameter, we are creating a semicircle. So semicircles have the two endpoints that could create a diameter when they are connected. Okay, so the other two possibilities are a minor arc and a major arc. A minor arc is just an arc that is smaller than a semicircle. So again, you can take a look here. This little red arc here is definitely smaller than half of a circle. So we would call that a minor arc. And if it's larger than half a circle, we will call that a major arc. Okay, so you can see there's some notation here. And we're going to look at an example with the naming down here. Okay, so we have to be able, again, to name these. So if I was talking about naming an arc, okay, if I want to name a major arc or I want to name a semicircle, we are actually going to use 3 points on the circle. The two of them are going to be where does the arc begin and end, and the third one is going to be any point between them in the direction you want to travel. Okay, so before we even talk about minor arcs, let's just discuss what this means. So let's take a look at this example and say that I would like to travel around this circle to the left. Okay, and we're going to go from A to C, which means we're going to draw ourselves a semicircle, right? So here's the arc I want to measure. Start at A. Okay, I want to go this way. Ooh, I'm terrible at drawing curves with my pen tool here, so let's try this again. Okay, so I'm going this way around the circle. Okay, and then I'm ending at E, right? So I can say this is definitely a semicircle. It's because when I connect from A to C directly, I'm going through the middle, which means this is a diameter, AC. So that means that this purple arc does represent a semicircle. Okay, and then I'm going to name this by basically saying I want to start at A, okay, I want to end at C, but if you notice, I could very easily take the right-hand path and I could go this way around the circle and end up at C. So I need a third point in between A and C, which describe the direction that I'm going to travel to get there. So I'm going to go, in this case, to the left, which means this point E is important so that everybody knows in which direction I'm traveling around the circle. I'm going A to E to C as opposed to A to B to C, which would be a different semicircle. And then we just put a little arc, kind of a half curve over top of this to specify that it is an arc. Okay, if I were to extend this now and say, you know what, I don't want this to stop at C, I want it to keep going, and it's going to go all the way around here to B. Okay, this arc now is a major arc, and it is a major arc because now I'm traveling a full semicircle and then I keep going, right? So it's more than a semicircle, and so again, we name this in a very similar way. We're going to use the two endpoints, right? So for us, that would be it starts at A and it ends at B, and then we're going to use any point that is between A and B in the direction that we're traveling. So I could also call this AEB. I could use this point E, or if I wanted to, I could also use the C. Both of these are showing us are points that are on the purple arc, so I can use either of them. I'm going to call it ACB, right? So it doesn't matter. We could have called it AEB, and we'd be talking about the same arc, right? So again, I'm going to use those 3 letters, okay? So the other possibility is maybe I want to go the short way from A to B. Maybe I don't want to travel this direction. Maybe I want to just travel directly from A to B instead of passing through all those other points, right? So I could also measure this direction, this arc, okay? Excuse my terrible drawing, okay? So this is what we would call a minor arc, and it's called a minor arc because we're definitely not traveling all the way around to C. We actually stopped before we got to halfway. So this is a minor arc, and when we do this, we just use 2 letters, and those are the endpoints, right? So if I just give you 2 letters, and I say, we're going to go AE. Well, you know that that is the shortest path from A to E, and it should be less than half of a circle. Once I start traveling more than half a circle or exactly half of a circle, we are going to use 3 letters to name those, okay? So let's just do a couple of quick examples of these, okay? And then in the next video, we'll talk about how to actually do the measurements of these arcs, okay? So if I asked what are the minor arcs in here, I'm going to look at this picture and say any segment, any little piece of this circle that is less than 180 degrees, which means less than half of a circle. So I can say there's arc AD, okay? And I could say this little piece from A to C, that is also 1, so I'm going to say AC. Okay, and then I can go from C to E, that is definitely smaller than half of a circle. I can go from E to D, okay, and I can go A to D, we did already. So it looks like I got all. There's 4 minor arcs. And when talking about semicircles, remember we said starts at a diameter, ends at the other side. And since I have 2 diameters here, I actually have 4 semicircles. I could go start at C, travel this way, which means I'm going to go through E and end up, sorry, I said start at D, go to E and then to C. So I can say DEC, okay, with a big arc over it. And I'm not going to say like CED because that's the same thing again, but I could go above this diameter and say CAD, right? That would be the other half of the circle using that CD diameter, okay? So if you notice, both of these started with C and D, but the E tells us that we're going to go below the diameter, and the A says we're going to go below. But I could also use this AE diameter. This also starts on the circle, goes through the center, and comes out the other side. So I could start at A, travel in the direction of C and end at E, right? So I could say ACE, this is also a semicircle, and then I could do the same thing, but I could go below, right? And I could say ADE, right? And this would also be a semicircle, okay? So 4 different examples, right? Minor arcs, semicircles, and again, we could do a major arc. If I started at A, for example, and I wanted to go all the way over to C, but I wanted to take the long way, I could call this, for example, AEC, right? Going all the way around to the end.